Okay, Unit 8 Lights, Notes 2, Practice Problems Part 2. We're going to work on practice problems 9 through 13 in this video. I'm also going to throw in a couple of extra problems to kind of help with understanding of the unit and the ray diagrams, so let's get to it. Number 9 says, complete the following ray diagrams and determine if the image formed is virtual or real. Well, you can use the little diagrams that I showed at the end of the lecture video, but I actually have a set of rules on how to complete ray diagrams. So these are the rules that I like to follow when drawing these ray diagrams. So let's go ahead and just follow along with the rules and see if we can try to figure out what the reflection will look like in this for this arrow. So we have a concave mirror, right? And for the ray diagram, what we want to do with this concave mirror is draw a horizontal line from the top of the object to the mirror. Okay, so here is from the top of the object, so here, all the way to the mirror, and we're drawing a horizontal line, just like that. Okay, so we know that any horizontal line that comes in through a concave mirror, the reflection has to pass through the focal point. You can actually see here, let me move this so that you can actually read the whole thing. There we go. Yeah. Okay, so we know that the reflection of that ray has to pass through the focal point. So we can draw the reflection going like that, just like that. Okay. So the next line, I'm going to draw another line. It's going to tell us to draw another line. I'm going to do it in a different color. Draw the line from the top of the object to the center of the mirror. Okay, so draw a line from the top of the object to the center of the mirror, just like that. And then step 4, draw the reflection in the same angle. So what I mean by that is that the angle here, going from here to here, is going to be the same angle as the angle from, let's do like purple for instance, from here to here. So we don't know what that line looks like yet, but let's go ahead and actually put that in. So that line, if we're kind of estimating going at the same angle here, yeah, sure, something like that maybe. Okay. Actually, let me try to fix that because here. So we can move this line segment out of the way. This has to pass through the center. And then I think this one, the angle, if I'm looking at it right here, I have to kind of look at it sideways. Kind of like that. All right. So what we're noticing here now is that these lines don't intersect. This red line, so I'm going to point out this red line here, right here, and this blue line do not intersect, right? And if you recall in the notes, what you have to do with these lines that don't intersect, these reflected rays, you have to draw their imaginary counterparts on the other side of the mirror. So what I'm going to do is actually draw the imaginary line that goes like this. I'm going to do it in a dotted line for that. And then for this blue one, I'm going to do the same thing. I'm going to draw a dotted line going from here like that. All right, so obviously they're going to intersect somewhere off of the screen, and that's fine, right? And when they're intersecting, that's the top of the image. How do I know that's the top of the image and not the bottom of the image? Well, it's because I was measuring from the top of the actual object. So since I was measuring from the top of the arrow, that's what's going to be up here. So if I start drawing this thing, there's the top of the arrow. I'm just going to crudely draw this, like not very realistic. But I'm just going to fill this in, and then you can kind of see that that's the arrow, just like that. So to answer the question, is this a virtual or real image? Well, in this case, this is a virtual image. And is it magnified or reduced? Well, it got bigger, so we know it's magnified. Magnified. All right, that was number 9A. Let's try 9B. All right, 9B is going to follow the exact same rules. Complete the following ray diagram and determine if the image is formed virtual or real. So let's do the same thing. The first step is draw a horizontal line. I'm going to do that one in red from the top of the object. Notice that the top of the object is now pointing down. It's going the opposite way. It's going to go from the top of the object, and it's a horizontal line. So that means that the reflection, step 2, has to pass through the focal point. And once again, the letters got kind of cut off here, so let me try to fix that. There we go. Has to pass through the focal point. So it's going to go something like that. right? And now I'm going to draw the second line going from the top of the object to the center of the mirror. All right, and when it comes back, when it rebounds back, when it reflects back, it's going to come back at the same angle that it came into. So something like, probably like, maybe like this, right? I'm just kind of guessing. That might not be the exact angle, but for the sake of this uh, problem, it's kind of close enough. So we drew the reflected rays going the same way. Did they intersect? That's the question they want to ask. I guess you can add it step 6. Did they intersect? So actually, it'd be 4B's, like here. Did they intersect? If yes, you don't have to do anything else. If no, you have to continue to step 5 where you extend them. So if we were to extend these lines, let's just, for the sake of this problem, kind of for practice, extend these lines and see what happened. So the imaginary line for this one would go like this. The imaginary dotted line for this one would go like this. You can see that going this way, going to this direction, they are never going to extend. So what you need to do is find where they intersect. If they already intersected there, perfect. So what we're going to do now is draw the top of the arrow there, because that's where the object reflection was measured from. So just like that, and then there's the arrow. Okay? So I can already kind of tell that I kind of drew this wrong, and I'll tell you why in a second. Um, Actually, I'll tell you now. It's because the arrow looked bigger than the original, so I think it's because this didn't intersect quite that well. So I think if I readjust this line to actually where it's supposed to be, something like that, you notice where the point where they intersect got changed, but that's okay. Um, at least these angles are a little bit closer to what they are. So if I start drawing this arrow, it's going to look like this now. Oh, let me try that again. So, okay, a little bit better. So the question is asking, is this virtual or real? Well, we know that this is a real reflection. And how do I know that? It's because the original image is pointing down and this one is pointing up. So this one's upside down to this one. So that's how we know it's a real image, because real images are upside down. Another question that I have for you for this problem is the reflection reduced or magnified based off the original object? Well, we know that it is going to be reduced because it is indeed smaller. And how I know that is because the object is beyond the center of curvature. And we talked about that in the notes, how if an object is beyond the center of curvature, it's going to be reduced in size. And that's why I had to adjust this line earlier, because the original line, when I had it, it was somewhere like up here. Okay, so that would have ended up with a magnified image, which would have been incorrect. So we have a smaller image here, which produces a reduced magnification. All right, so we have another example problem. This is not in your practice problems. This is just another practice that we are going to do in order to get this concept down of the concave mirrors and their reflections. So let's go ahead and practice those rules. If you need to refer to those rules, you can, but I know them, so I'm just going to go ahead and try to practice without using them. So I know the first step for any object that I have with a concave mirror is to draw the reflective ray going horizontally and its reflection. And I know that if I have a horizontal line, the reflection has to pass through the focal point. So I know it passes through the focal point just like that. All right, and then I'm going to draw another ray going from the top of the object to the center, and then from the center, we're going to have another one that kind of goes off at the same angle. So something like that. All right. I can already tell you that these two are not going to intersect. So let's go ahead and draw their reflections. Give me 1 second. Okay, so we're going to go ahead and start with this one since we already have blue selected. To my best ability, it's something like this. I'm just going to draw a really long line. And then for this one, I'm going to draw the imaginary line going on the other side of the mirror. Something like that. Okay, so what we can actually do now is draw a shape that is similar to that red arrow. But it's going to be obviously much larger because that's where the top of the object is. So we're going to end up with the red arrow This is going to be kind of big, so I'm just going to, again, draw a little sketch of it. Something like this. Alright, so that's the magnification of that red arrow. This is producing a virtual image, and it's magnified. How do I know it's a virtual image? Well, they're both pointing in the same direction. The first arrow is pointing down, the second arrow is pointing down. So they're both pointing down, they're not upside down to each other. And so they're pointing in the same direction, therefore it has to be virtual. And it is magnified because the reflection is much larger. Okay, let's try doing another practice for us. This is not in your practice problems, it's just for us. We're going to start by reviewing the same rules. The first rule being draw a horizontal line from the top of your object to the mirror. And the second rule says the reflection of that ray has to pass through the focal point. So just like that. All right, we're going to try to do the third rule says to draw the line that goes from the top to the center, and then from the center, that reflected ray has to bounce back at roughly the same angle. So I'm trying to visualize this somewhere like there. All right, number 4 says to draw, actually that was rule number 4. Number 5 says to draw the intersecting rays. If they don't intersect, well, I can already tell that they're going to intersect. I'm just going to make this line a little bit longer, and then the other line as well. So we're going to do just this line. Come on, there we go. And then make that one just a little bit longer so we can see that they intersect right there. All right, so let's go ahead and draw this pentagon that we have. So we know that that's the top of the pentagon. Where they intersect, that's going to be the top. So it's going to be like this, and then like that, like this, and then like this. Something like that, okay? I know it's not the best artistic representation. We're just doing it to show what kind of reflection it would have. Well, is this pentagon upside down in relation to this one? Yes, it is. So this is going to be a real image. And is it magnified or reduced? Well, it's magnified. And we know that because it's still between the center of curvature and the mirror. We reviewed that in the notes as well. Let's do some practice multiple choice here. So numbers 10 through 12. 10 says a real image can be formed using a what? A concave mirror, a convex mirror, a flat mirror, or all of these? Well, a real image can only be produced with a concave mirror. So just keep that in mind. A real image can only be produced with a concave mirror. A convex mirror produces virtual always, and a flat mirror will always produce virtual images. All right, number 11 says a virtual image appears where? Does it appear in front of a mirror, appear behind the mirror? Does it diffuse light, or does it reflect light? Well, if we go back to the notes, we know that a virtual image always appears behind a mirror. So just keep that in mind, that the virtual image is always appearing to be on the other side of the mirror. All right, number 12 says when you look in a convex mirror, the image appears smaller than it really is, lighter than it really is, larger than it really is, or darker than it really is. In a convex mirror, kind of like the side mirrors of a car, the objects in the mirror always are going to appear smaller. Okay, so just keep that in mind. A convex mirror will always make things look smaller than they actually are. You can see more with a convex mirror, like your field of vision, your range is going to be wider, but the objects are going to appear to be smaller. All right, number 13. Complete the following ray diagrams. So we are no longer dealing with concave mirrors. We're doing convex mirrors. So let's try to do these ray diagrams. The same rules apply to both concave and convex mirrors. It's the same rules. First rule being that we're going to draw a line going from the top, and then this one goes through the focal point. But here's the thing, you can't see the focal point because it's an imaginary thing. It doesn't actually exist on the other side of the wall. Because remember, in real life, there's probably like some type of wall here or something. But geometrically, yes, the focal point does exist. So I'm going to draw it going from here to here as a dotted line. And then on the other side, I'm going to keep drawing it like this. Whoops, wrong tool. Let's select this one. On the other side, draw it going straight like that. All right. Then you have to draw the next line, number 3. Draw a line going to the center of the mirror. Just like that. And then the reflection at the same angle. So the reflection goes off at the same angle. Something like that. That should work. And then draw an object at intersecting lines. Well, for this one, you do need to extend it onto the other side. So this is the imaginary line, the line that doesn't exist. And yes, they do intersect right there. So we can go ahead and draw that shape. This arrow is going to look like this. So a little arrow. All right. So what type of reflection is this? Well, this is virtual. I know the question didn't ask for it, but we're just going to write it. This is a virtual and it's a reduced reflection. Let's do part B, 13B. So the rules again say draw a line going straight, hits the mirror, the reflected ray has to pass through the focal point, but this side is going to be imaginary. And so if we continue onto the other side, it's something like that. And then for the next line, go from the top to here, and then it bounces off at the same angle, something like that. And then I'm going to draw the imaginary line for that. Something like close to that maybe. And then it's pretty similar in size, but it's still going to be, you get the idea. It's still going to be a virtual image. And even though it's still pretty close in size, it's going to be reduced. How do I know that? Is because a convex mirror will always produce a virtual reduced image. We're going to try a couple more problems with convex mirrors. Again, these are not in your notes, just a simple review. So let's take a look at this red rectangle and see what the reflection would look like. So again, the first rule being that we would draw the first line going across, and that would look like this. And then the reflection, of course, has to go through the focal point, but it's on the other side of the mirror that we can't see, so it's just an imaginary line that looks like this. But if we were to extend that out, the reflection actually looks like that. And we know the reflection goes at this angle because it still has to pass through the focal point. And then we draw another line going from the top to the center of the mirror, and then it bounces off at the same angle. And then for this one, we can actually draw the imaginary line of the reflected ray going all the way through. And then at that intersection, that is what we're going to draw our, that's where we're going to draw a rectangle. So the rectangle actually looks like this. All right, the last problem that we're going to work on is drawing the reflection of this right triangle in a convex mirror. So starting from the top, you draw a horizontal line going to the mirror, and the reflected ray hits the focal point, just like that. Then you draw another reflected ray going from the top to the center of the mirror, and then it bounces off at the same angle that it came in on. And then you extend that reflected ray until the two reflections can intersect. And at that point, that's where you draw your object. So that's what you would get. And even though these two triangles seem close in size, this one is smaller, so you would still get a virtual reduced image.